So welcome back. In this lesson, we are going to learn how we can implement step 2 of the decision tree algorithm, right? So in this step, we are going to find the best split. So we want to find the order of feature splitting. And in order to do so, we calculate the information gain of each value in the attribute list. So we will try all the values for this specific column, get the information gain, and then we get the optimal split value, which corresponds to the one with the highest information gain. So let's see how we can implement this function. So we will call this function find best split. The input is of course x and y and the split attribute, right? So the split attribute, we got it from step 1. So this is an input for this function. Okay, it's corresponding to the column of x on which we want to split. And the output of this function should be two things. First, the best split value, so the optimal split value for a given attribute, and this is of course the input for function 3 or step 3, and we want also to get the best information gain. So this will correspond to the value of the best information gain. Now, for this function, as we said, we want to compute and return the optimal split value for a given attribute along with the corresponding information gain. So how we can do so? Let's first see an example. So this is the same example we saw before. So we have x 5 examples, 3 columns. And for y, we have the labels either 1 or 0. Okay, now let's say we have the split attribute from step 1 equal to 0. So we will start the entropy, or the starting entropy will be 0.971. So what is the starting entropy? It's the entropy of y, right? 1, 1, 0, 0, 1. This is the entropy of y, of these values. Okay, so we want to calculate the information gain at all the splits. We will not say 1 or 2 or 5. We will try all different splits. Okay, so we will choose a split value equal 1 and then calculate the information gain. And then split value equal 2 and calculate the information gain. Split value equal 3, calculate the information gain. Split value number 4, calculate the information gain. And then finally, split value equal 5 and we calculate also the information gain. So as we can see here, the split value equal to 4 corresponds to the highest information gain. So we will split based on 4. Okay, so the value we are going to choose to split is 4. How we know this? Because we tried all different combinations. That's basically how we did so. So we know from this that the best split value is 4 and the information gain corresponding to this split value is 0.32. Now let's see how we can implement all this in Python. So the first thing is that we are going to create a variable called best information gain, and we will initialize this variable with 0. Okay, and we want to make sure also that we have a numpy array. So I'm converting x just in case to a numpy array. Okay, after that we are going to get the column split just like in the other function, right, in step 3. But what is different here is that I am getting only the unique values of this list, right? Because we want to try only the unique split values. Because if we have one and then we have another one, then we will get the same information gain. So it doesn't really make any sense to use the same split value twice or more than twice. Okay, so in step 3, we needed to find all or get all the column splits, right? We needed to get the whole list, right? The whole column. But here I want to get only the unique values. Now we will do so using numpy.unique. And we will initialize the best split value to correspond to the first value in the column split, right? So if it's either 1, 5, 6, 7, it doesn't really matter. The split value for now will be the initial one. Now, what we are going to do is that we are going to loop over all the split values, just like what we did here. So for split value in column split, we will call the partition classes function. So as you can see, we are using our implementation of step 3 in step 2. Okay, so we are called partition classes with x, y, but with also all the different split values. So the split attribute will be the same each time, but the split value will be different, right? And each time we will get current x left, current x right, current y right, and current y left. Okay, and here we are creating a variable called current y, and for current y we are going to append first the left y and then the right y. So the current y will be, as you can see, a list of lists. So it will contain in the first index the left hand side y, and then in the second index it will have the right hand list or the right hand y. Okay, and then we are going to calculate the information gain just like before, just like what we did when we tried or tested the functions. So we will call the information gain using y, right, the complete list or the complete classes before splitting, and current y after splitting. Okay, so this will give us the information gain. So how we can know if this is better or not than the information gain we have before? Very, very simple. We will have a condition here. So we will say if current information gain, the one we got right now, is bigger than the best information gain, then the best information gain should be the current information gain, right? If it's more than the best information gain, then it should be the best information gain, right? And the best split value will be the current split value I have, right? So I will loop over all the unique values in the column split until I find the best information gain. And basically I will return from this function the best split value and the best information gain. So this function is very straightforward. The trick in this function is that we are calling the partition classes many times. Each time we are calling it with a different value corresponding to the current value in the split column, and we are also calling the information gain function we implemented before, right? And inside the information gain function, of course, we have the implementation, or we are calling the entropy function. So in the next lesson, we will see how we can implement the last step, or step number 1, which is find best feature, right? Because right now, the input for this function is the split attribute. So what if we want to calculate the split attribute, or what if we want to get the split attribute ourselves, right? So in the next lesson, we will see how we can do so. So let's go.